coming up at 2:15 p.m. Eastern Standard Time, God's Standard Time, is the wonderful, beautiful, and talented Niko Neugebauer with Columnstore Indexes. What are we waiting, or what are you waiting for? What is who waiting for? Who, or is it we or is it you? You have to explain.
I don't think Niko's waiting for anything.
No, Niko's ready to go. All right, with that, I'm going to bow out and finally use the restroom. Niko, good luck. Break a leg.
So, ladies and gentlemen, welcome to the worst session of this conference, which is Columnstore Indexes. What are we waiting for? So, gentlemen, should I introduce you or will you introduce yourself? The both two fine gentlemen who are accompanying me here.
I'm just along for the ride, Niko. So you go ahead and run with it. I do have one question. Do you want questions throughout the session? Do you want us to hold them to the end? What are your thoughts there?
Let's do them as we do the presentation.
All right.
And it's just like, don't interrupt me when I am saying something which I pretend to be of some meaning, but after at the end of every slide, I'm absolutely positive for the question. All right? Okay, let's go. So what are we waiting for? We're waiting for these presentations, ladies and gentlemen. My name is, as you can read, and my title you can also read, and you can read where to find me on LinkedIn or on Twitter to follow me, blah, 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 blah. Very fine stuff. If you Google for my name and put maybe something like SQL, you should be able to find me. Yeah, nothing interesting. I'm breaking the rules. I enjoy breaking the rules, the good rules. So what are we talking today? We're talking about logical fragmentation? No. We're talking about the dictionary creation? No. We're talking about Baucode API? No. We're talking about root analysis? Well, maybe. Are we talking about the weight types? Yes. So what are we talking about actually? What are we waiting for? We're talking about the Columnstore weight types. We will be talking about the Columnstore indexes and the batch execution mode. So please raise your hand if you have never heard about the Columnstore indexes. How many people have raised their hand, Anthony?
Yeah. I don't see any in the interface.
Okay, that's fine. Well, we can't see them in any case. So I'm talking about the Columnstore indexes, and I'm not talking about a kind of, I call them unfinished, still can be useful, but you gotta push them against the wall. Columnstore indexes in 2012. I'm talking about the clustered Columnstore indexes mostly, and non-clustered Columnstore indexes, starting with 14 the clustered Columnstore and 16 the non-clustered Columnstore. So this picture is almost in any presentation of mine when I'm talking about the Columnstore indexes. We got all these fine structures. The row groups, they are compressed with different degree of success, because most of the time they will have a different kind of the data. We have the delta stores. We can have one or multiple delta stores per index or per partition. It's a source of huge misunderstanding and huge part of the Columnstore indexes problems. So what are those delta stores? It's a typical way of loading data into the Columnstore indexes, but let's say not the efficient way. But these are the trickle inserts, because actually if we talk to somebody who's running different type of the Columnstore indexes outside of the Microsoft data platform, they will laugh, and sometimes they will even make fun, like, yeah, so you've got the Columnstore part, which will be the row groups, and you've got the row store part, because delta store, it's starting with 2016, it's an uncompressed source of data. This is how you land the new data into the Columnstore. If you are loading in the regular inserts or bulk load API less than 2100, 2400 rows. So delta stores are, non-efficient way of getting data into the column store. They can be open, they can be closed. We've got this deleted bitmap, very fine thing. It's a B tree structure, basically 1 bit per every single row within the row groups, where we mark the row as active or deleted. We've got the delete and update operation we can run, and where update works as the marking the row within the compressed row group as deleted, and then insert and merge the updated data into the delta store. Basically, why shouldn't you ever run merge and update against the clustered column store if you can? First of all, merge is buggy in the way that how it works with clustered column store indexes. It's beyond slow, and I'm scared of seeing any merge operation. And update is slow. Why? Because it doesn't work in the batch execution mode, and because it will not use something which is called a hidden row group. This is how you load the data fast into the column store indexes. You will be using more or equal 100 and 2400 rows, and this is a very efficient way to load data into the column store indexes. So what changed in 16 and 17? We've got more structure. Really sorry for the ugly picture. So this one I was drawing while I was blogging a couple of years ago, so it's ugly. Beg for your forgiveness. Essentially, in 2016 and 17 and 19, we have a possibility of not building on the table only clustered column store, but we have also the possibility of adding the non-clustered secondary row store indexes. And these are compressed row groups. This is still the deleted bitmap, one, multiple, or none of the delta stores. And here we are one or multiple non-clustered row store indexes. This is a really smart thing, which is called mapping index. And I actually confess of trying to torture it in a good way, making it produce any bug or delay, making it a source of problems. Never managed to do that, and diving into its implementation bits and bytes. Really, I'm like really smart implementation. So what does this mapping index does? It connects the it helps you identify the row within the B tree and connect it with a concrete row group and the row locator within the row group. Okay, I'm sorry if this is kind of a little bit fast and advanced presentation, but this is how it's supposed to be. Non-clustered column store indexes in 2016 and 2017. They got updatable. It was like the finished non-clustered column store index. And we have the B tree structure. We have clustered row store index. It might be heap, doesn't really matter. You get for your non-clustered column store index the row groups, deleted bitmap, one or multiple or none of the delta stores, and you've got a deleted buffer. Deleted buffer is actually not one, but the real implementation, there are two of them to serve you in the best way possible. Every time you delete a row within your principal row store structure, instead of scanning deleted bitmap and potentially slowing down the insert, update, and delete operation, you will, if you are updating or deleting a row within the compressed row groups, the key for the operation will be stored within deleted buffer. And when you run the outer index reorganize or the tuple mover is running, it will synchronize the deleted buffer with the deleted bitmap, and everything will work as before. So a question, do you see any potential sources for the problems here so far in this architecture?
The updates become pretty expensive.
Updates are always expensive. So actually, I was talking to some very smart gentlemen from Netherlands and UK. Some of them were telling me, so in some huge installations in PDW, APS, or post PDW and APS world, you do everything you can in order to avoid any updates or merges. You do delete insert. I've been told this many years ago, and I try to follow this principle. So just a little bit of the processing part for the non-clustered Columnstore Index. We read the row groups, the data. We read the rows which are marked as deleted, and we see if the row locator is not in the row groups, then they pass through. If not, we eliminate those rows. Then we join the information with the deleted buffer, and we pick up these keys which are removing the data, and then we finally join with the delta store. So this is actually, I'm not even making this question, I'm making an affirmation. The expectation of non-clustered Columnstore Index is not to be faster than the clustered Columnstore Index. Because if you rewind here, this architecture, you see there is one deleted row structure. Just one, it's here on the left side. When we go to non-clustered Columnstore indexes, there are two of them, deleted buffer and deleted bitmap. And this part of the deleted buffer, this is an extra operation. Because when you're processing, when you're reading the data, you will ignore the mapping index, even if you have the secondary non-clustered row store indexes. So non-clustered Columnstore index processing will be equal or slower to the clustered Columnstore index processing. So will we have here some huge problems and differences between them? I do not expect. I never saw them, and I do not expect them to appear. So just a slide about the in-memory Columnstore. Here we do not have in the architecture the deleted bitmap structure. We have a deleted rows table where we just store the IDs, the keys of the rows which were deleted or updated. But it's in-memory Columnstore is a different game, and I hear about some people who are starting to use it in production, and they actually doing pretty well with a good success. But I guess the in-memory is still kind of not the favorite kid on the block, which I think is quite unfortunate. But let's hope Microsoft will start investing a little bit more into it. So let's take a look at the point of our presentation. So I covered the basics. If you are not up to the principal architecture when I mentioned it, I recommend if you Google for Niko and Columnstore, you will be able to find my blog. I have over 130 blog posts in the sum on the matter, and pick up the bits and get back to this part, because this is I'm trying to look a little bit deeper. Any questions before we go into the real presentation?
None so far.
People are probably sleeping. It's late here. All right. So I think it is very important to understand there is a difference between the word heal and the word cure. There is a difference, and it is between the patch and resolve. When you've got trouble, you can patch, but patch is not a solution for the problem. Patch is, you hammer. If you have a boat and you have a leak, you put some metal or whatever they apply, you hammer it to the place where you have a leak, and is it solved? Well, it's not. It's patched. It's different. And I try to start with the patch if it hurts, which would be heal. But I tend to go into the resolve. This is what interests me because, you know, patches are only capable of, you know, staying for some certain amount of time. And depending on the kind of the problem, patch can be very, very, very temporary. And we can throw, you know, very exotic solution for some query. And is this a resolution? Well, sometimes it is, but a lot of times it's not. Cumulative update, a trace flag will interfere in the next SQL Server version, and you'll get into trouble. So how does SQL Server and Azure SQL DB works? We have an application, whatever it is, you're running your management studio application. You send a request, it's placed in the queue in the SQL Server memory, and then a free thread from thread pool will pick the request, compile, and execute it. And then the statement can read and modify the data. As to a company, you can basically see that we start high and conceptually outside of the SQL Server, and we go down, down, down. And I see it at every level gives us a better understanding of the problem. And from better understanding, we can go one step further and decide how we resolve the problem. Maybe also how we patch the problem, but it's, you know, I Googled the Stack Overflow, I found a solution. Well, it's not a solution, you found a patch. And I just, yeah. And I tend to go into, I'm interested in finding solution, the cure. So when we are already running our statements, we're reading, modifying, inserting our data, when we see the things that makes us wait a lot of time, unless some of the waits appeared before. So locking, I guess everybody working with SQL Server for more than a couple of months already faced problem of locking. And then we go into the latching potential. These are the internal wait times that are spent waiting for the certain system resources most of the time, okay? And we're going finally into the wait. Because for me, waits are the way of understanding what is going on. What are we waiting for? Are we waiting for data to be read into the memory? Are we waiting for the query to receive a memory grant to start processing because it's going through the biggest, hugest gateway, whatever, because we need like 5 terabytes of memory, whatever it is? Or are we waiting for the data to be read from the disk into the memory? Or maybe these are some of the system tables that are blocked and we cannot get to the resource we are requesting. Maybe it's locked. Maybe we're waiting for the ledge. Or maybe we have a chance of looking into the internal processes and understand if those internal processes, the real programming code, is doing something that it's not supposed to. Maybe it is a bug. But these are the things I consider to be important. These are things I strive to understand. Do I understand them all? Of course not. I guess, like, I don't know, Bob Ward, Joy Hobbies, I don't know, Paul White, Dmitry Pilugin. These are the guys who I'm looking up to. These are the guys who understand the real stuff. But I'm trying. I'm trying. So these are the hierarchy of the performance analysis. And it's not Maslow's needs, but it's the process. It's the execution plans. It's locks, it's ledges, and finally it's wait. With every year overall, I tend to go and look more and more into the weights, because I think that the weights are telling a more detailed story. And sometimes when looking above on the higher level needs, we see something that we interpret in a different way as or opposite of when we're looking into the wait stuff. So how do we analyze any execution in the SQL Server? Well, my query is slow. Okay, let me run on the production this big query again and see if it's slow. That was fast. Try it again. Oh, this is slow. Nobody can connect to SQL Server. Okay, we found the problem. This query is slow. Very good. You just killed SQL Server. Maybe, you can extract a backup, restore, you run, you analyze. Maybe you use DBCC clone DB. You can see the execution plan. You understand that you are getting a very ugly execution plan with wrong statistics and so on. Yeah, you need to run them. That's the first step. Well, maybe sometimes you can, if you have errors, you can look at the errors. And if you are on 2019 SQL Server, which is still not released by the time I'm presenting the session, or maybe you're looking at the 2017, which already has a trace flag in order to see what is being truncated. Maybe you find out what is the exact problem, okay? But what to do if, if you can't get to the error message, or if everything is fine, but the query runs slow, and maybe it runs sometimes slow. Logs, very popular way of analyzing, and I guess we all do when we run something like monitoring for the queries. We're looking at the logs. This process is being blocked by somebody, and it's waiting to get its necessary exclusive log. Latches, yeah, well, we can analyze them, but well, it's a kind of I think it's not the thing as strange as it will seem. I think that the latches are much less accessible and rare than the waits, and this is what I enjoy more and more time. And especially we can enjoy the wait types more in the REST and SQL Server versions, because Microsoft was so fine that they inserted the possibility of seeing them within even the execution plan. I think it's absolutely brilliant. There are items we can discuss if it's completely what we are looking for or not, but it's just, I'll praise Microsoft once again for delivering us, and the Tiger team who is doing an incredible job once again. So wait, well, all of you can read. If you are just listening to the recording, then you are out of luck, but if you want, I'll read you, maybe because I didn't thought about this possibility. So when the thread cannot proceed because some resources are not available, it will have to wait for this resource, and this time is defined as wait. Example of the resources that one can wait for is a disk. For example, we send a request just like, grab me some information from the disk, scan this table, get this data, like seek this index. And when the index is trying to get the information, when the disk is not returning the information to the process, this is the wait time. Or maybe we're waiting for the memory grant because, well, the resources are not unlimited. Maybe we'll have to wait for another thread to finish. And regarding the object of this presentation, this is a very typical situation, as you will see that another thread to finish is a typical parallelism. I'll group it as under one umbrella of parallelism. You will wait for a parallelism because, as you all know, you cannot get all the processes to finish at the same time. You're running with 8 cores, 16, 32, 64, whatever, how big your first process is, you will be waiting for them to, 1, 2, 5 of them finish at one time, and some of them can wait, can take some significant time to finish. SQL Server tracks hundreds of them, of the wait types. I don't know, 1,500. Anyone of you gentlemen has an idea of how many wait types are right now in 2017? Am I already alone in the presentation?
No, we're still here.
Well, okay, let's agree. I think it's just like, in my head, it was like 1,500, 1,800. Wait, you can Google. I can't, because I can't impress people with my knowledge. But this is.
I'm Googling. I'm Googling.
And so, what does the bean tell you? Maybe people are falling asleep. In some countries,
Andrea says she was just reading the slide. She says it's well over 1,000, 2017.
Okay. I think actually 1,300 was like 2014 or whatever. Anyway, let's advance. So execution process lifetime. We have three main states for any process. We're running, we're suspended, or we're runnable. When we're running, we are not running continuously, because I mean, unless you want, you know, if you start four single core processes on 4 cores, you know, if they would run for all the time, you would not be able to start the 5th process at all, unless one of the previous 4 processes would come to an end. So you have this, like, the 15 minutes of fame for the SQL Server are the 4 milliseconds. This is the time it takes for this quantum of execution. You have your 4 milliseconds, then you go suspended. When your thread becomes suspended, your process becomes suspended, it will see if it needs, you know, will I wait for some resources? Do I have all I need to keep on running? Then it will become runnable. When it becomes runnable, it will have to go up through the queue of the runnable processes, when it will be peaked, and it will be moved into the 4 milliseconds fame phase, and it will circulate until it will finish. So imagine I have an ID 100, we start, we have all the resources, we don't have to wait, we go into runnable, we go through the queue, all other processes, they went through the execution phase, we are on the top of the queue, we jump into the running, we get our 4 milliseconds of fame, we go into suspended, and now we do not have the resources. Maybe we're waiting for some threads to finish, and we will spend the time waiting. And these are the waits we can observe, some of the waits. Well, I'm not going into the details between the signal waits, which would be the time we spent going through the queue, and I'm mostly talking about the resource waits, which are when we are in the suspended phase, waiting for some real resource to give us an okay, a permission to advance. Any questions?
No, this is good.
Yeah.
Is the I'll give you a question. So is that queue, the runnable queue, is that a fixed FIFO queue, or is there some intelligence in selecting the processes that go from runnable to running as it pulls things out of the queue?
So to my understanding, and I think it's a great question, because I will not be able to answer it in a competent manner, but you have different queues. You have the different queues for the execution, which are connected with the resource, the semaphore gates. Sorry, it's the end of the day. So it's like when you're running a small query, a medium query, and a huge query. A small query will advance much faster through the queue than the medium. Medium will take more time because it will consume more resources. right? And the BigQuery, it's like huge gateway, I believe it's called. Before some fixes in 2014, 2016, you could run like just a couple of those BigQueries. And my expectation, not my knowledge, but my expectation is that going up through the queue will correspond the gateway you have passed based on the number of the resources you are consuming. Because SQL Server does its best in order to, you know, to make all queries advanced, and there are, you know, decisions and the trade-offs.
Right.
It's a great question, and I'm admitting that I wish I would knew a little bit more of this. I will need to research, but I would be pretty confident about that it would work this way.
Yeah, Linux actually, that's how it schedules and picks processes to be selected to be scheduled, is a similar mechanism where to increase the interactivity of the smaller queries, but also not starve the larger queries and vice versa. So there's a little, like a maximum throughput, I guess you could say.
Mm-hmm. So there must be some weight, some weight, not weight like time weight, but depending on how heavy the query it is, it's assigned some certain number, like let's say 1 to the small query, 10 to the medium, 25 to the big, and 100 for the huge. And then there is an algorithm which will say, you know, we pass 3 100s, 2 3 5 50s, 10 of the others, and 100 of one. So a kind of equilibrium. And this is something which is, unless we are throttling the queries to make, you know, appear to consume less resources, like, you know, decreasing their memory, well, it's difficult to influence the execution process lifetime. We will increase the speed, definitely, when we move from suspended into runnable. Eliminating resource weight, that is essential, okay? So finally, like after whatever it is, 7 minutes, I'm starting to talk what I want to talk about. I want to talk about the Columnstore Indexes weight types. And even before, there was a batch mode on the row store, which will be hugely awesome in 2019. And don't expect it to be backported to service pack of 2017. First of all, because there are no service packs on 2017. And secondly, I think it will be worth good money for a lot of people to migrate to 19. Well before it was announced, I had for me, the separation of the weight types was a batch mode, because it's been always, as Joy and as Joy Abish was showing with the Columnstore injection hack, you could mix the row store and the column store with the batch mode well before 2019. So you know, the process is something which is mostly connected with the batch execution mode. And please use this presentation as a lot of points I expect to be still valid for 2019 batch mode on the row store. And the other thing is the architecture. Architecture weights, they are really connected with these complex architectures I was showing you in the Columnstore Index. And do not expect that you can influence a lot of things. You are able to influence some of the things, but it's mostly to your understanding and of what is running, and maybe you can understand that bigger parallelism, especially beyond 16 cores, should be used with a great responsibility. Because the more parallelism you got, the more synchronization you've got, the more weight you will get. I mean, if you're running everything with one single core, I mean, you will not be seeing the weights, but your execution time will also not be the fastest for the big amount of data, which is also logical. So
But
Yeah,
Niko, is that something that you've observed on your own, or is there a theoretical constraint there with regards to capping at 16 processors or threads in a query?
I have definitely observed this, and I used to tell to the clients, to enthusiasts, to friends, when we're talking about the query execution. If you look at the curve, and because I can't see myself, just have one screen here. Just tell me if I'm showing within the visible space for you or not. If you start with one CPU, of course I'm extrapolating. There are more exceptions than rules, but the rule is 1, 2, 4. There will be a linear progression, or expected, unless you are hitting limitations. You go to 8. And it's not the same line. It will start going a little bit less than a linear progression. You go 16, so it's this 1, 2, 4, 8, 16, and a lot of times you run the execution with 32 cores, and you expect it to go a little bit higher, but you will see a lot of 32 cores execution to go slower.
Right.
Compared than 16. And no matter what the feature is, you will observe these curves. And I wish it would be a different way on the big machine, but as all of us know, there are all the jokes about the parallelism problems. Parallelism is hard. Hard is parallelism. Hard is parallelism.
Yeah, I'm trying to pull it from the back of my brain, but I remember studying that in graduate school, where there's a plateau between 16 and 32 in multiprocessor systems, or even grid computers as well. So it's interesting to see that that's still the case in cutting edge technology, right?
I guess we don't have to forget that SQL Server, because we're talking here about specifically SQL Server, but I can tell you can observe not only on Microsoft, but you can observe a lot of the similar stuff on other operating systems, and not only SQL Server on Linux, but other databases as well.
Right.
Cutting edge is one thing, but if you look what SQL Server does, for me, it's the best general purpose database. If you will remove the general purpose, I guess the query optimizer team, all the architects of Microsoft, they can blow the socks off out of the performance. But you need to balance, and general purpose means you keep happy guys running small little queries on small databases. I mean, I've seen things which 18 instances on a single VM, 18 instances of the SQL Server. I've seen today 1,350 databases on a single instance of the SQL Server, and it functions and it delivers, and people are happy. So you need to balance those extreme cases with the cases when you're running a huge data warehouse. And I think if you are in the needs of processing huge amounts of really huge, not like I've got a big data, no, huge data. It's whatever big data, there is also a huge one, or huge, as some people say. You need to look at the MPP system, because MPP systems, they are focused on processing these huge queries. They are optimized for that. They're not optimized on running inner loop joins. If you're running on Azure SQL DW, I have 10,000 rows. It's a big data table. Well, I mean, the next day we'll see if it finishes. But if you put, I don't know, 10 trillion rows in a table, Azure SQL DW is a platform I would be looking at to process. Maybe you would go to, Hadoop, maybe you would do Spark. You need to understand the needs. And so this 1632 area, I would love to believe that 2023, I would expect, and I'm not a scientist, whatever, just expectation, when we start catching up on this space, where the queries will start improving. Because as the data will grow up, Microsoft will invest progressively more and more and make those queries run faster.
Right, right.
All right. I love talking about technology, my friend. I'm just like, it's so easy to put. I'm like this dog from the up cartoon. I'm like, squirrel. Any questions, or I will try to advance?
No, I don't see anything right now, sir.
All right. You called me sir. It's the first time. It's a bonus point for me. Thank you. So let's take a look at the batch mode weight. These are not only batch mode, but I use them as batch mode weights when I'm running the Columnstore indexes, but not inclusive, because HT does not stand for Columnstore. We would use a CC, or we will use, as you will see, the exclusive batch mode BP batch processing weights. But this is hash table build. These are the weights: hash table delete, hash table memor, hash table reinitialization, hash table repartition. You know, you're working with hash tables, and if you're working with the Columnstore indexes and you're working with the batch execution mode, even on row store, you will be working with a hash table, because, you know, batch execution mode is not supported for the merge joins and not for the inner loop join. And let's join our hands together and say, Microsoft, please do not waste the precious time of the engineers trying to make those two other types of joins work with the batch execution mode, because it doesn't make any sense. We've got the BP sort. So it's a batch processing sort weight. And we've got a pretty exotic one, even though lately I've been seeing more of this one, which is a p-weight query batch processing memory. You will see this one more on more busy, complex, huge number of parallel process running systems. Okay? The Columnstore indexes, the architectural type of the weights is row group version. I have actually an ongoing exchange, a different conversation, actually more than one on this one. People seeing this will be unreasonably popular, especially on the complex and availability groups based row group weight. Then the operational stats weight, shared delta store creation. Also a weight you will see, but these are the weights which are connected to the delta stores. And when are we using delta stores? When we are loading data into the Columnstore indexes with the trickle insert. I mean, I wish there would be like, I don't know, maybe actually, I'll throw an idea for execution plan one day to include a kind of a warning, like you are not using an efficient way to load into the Columnstore, because this is the source of a lot of problems. Not only locking problems, but weight problems. Because when you're loading the data, do not expect them like, oh, I have one process which will be loading. Yeah, you will be loading, and 10,000 people potentially will be accessing the same delta stores in parallel, and you will have to share the access times, and you will have to have the synchronization processes. And this is what will be making the access to those structures very ineffective. This one, I mean, if you ran 2012 and 2014 SQL Server, well, you know, extended events, this is the only way you could understand actually with this Columnstore build throttle extended event, how you could understand the reasons for the row group trimming. The row group trimming is a process when we are not reaching 1,048,576 rows, which is maximum, the perfect size for the Columnstore indexes row group. It's the throttle is when we are externally from the row group, but the query optimizer will say, you know what, I'll catch you at 500,000 rows. And this is something which will not make me or a lot of people happy. Column store migration background task. And I'm not talking about any illegal immigrants because it's not immigrant background task. I'm talking about the tuple mover and the migration of the closed or open delta stores into the compressed row groups. Tuple mover, just a reminder, this advanced presentation, tuple mover is a background task. That's why comes this part, which is run by default every 5 minutes. It looks for the closed delta stores, the ones that reach the maximum size over 1 million rows, and it will take them and compress into the row groups. And there are important ways, and there might be cases where you will say, you know what, I'm getting deadlocks and I'm getting huge wait times because of the tuple mover. And there is a supported trace flag and supported and documented 634, with which we can completely disable, shut down the tuple mover process, which can be pretty much useful. This one is listed as the possible column store wait type, but we'll see what it is or it is not. I'm not doing pretty well on this, so I will speed up. Any questions?
No, so far, sir.
Those people, everybody's probably finding like Niko is doing an introduction to the session. When is he? It's almost 1 hour long, and he's still introducing this stuff. So hash joins, ladies and gentlemen, the HT wait types. They are not exclusive to the hash joins, but you know, grouping data using the hash function will reproduce in a way this. So we have a build side, we have a prop side. With build side, we build a table with hash values. With the prop side, we pick we build for every row a hash value. We compare with the hash value from the build side, and we say, yeah, it's a match, it's good. And we'll say, well, it's not a match, then probably these are not the same values. It can get more complicated than that, but that's just the theory. So let's take a look at the HTBUILD. This wait type is related to the process of building the hash table, this one. Okay, so when we are on the build side, it's a time that we spend on building, making available for every thread. And if you're running a 2012 Columnstore indexes, you will be surprised, but it's absolutely different. It was a total rewrite of the process. You had right now we have a shareable hash table, which is shared between the threads. And in 2012, we had for every single process, it would build its own copy, which, you know, you think about the memory it would spend, but it would be hugely effective in a way. When you have enough memory, when you keep it there, you do not have the collisions. The synchronization of building the hash table is something that will be a time spender. So let me switch to my presentation, which is this one. I'm not running the queries. I will be just showing them. They take just a couple of seconds, but I'll try to speed it up. So I'm running here. I'm sorry, I forgot something which is called Zoom It, because I am very well organized. As you can see, yeah, I have no Zoom It. Any questions so far? Please fire them away as I'm proving my uselessness.
You may get to this later, but is there types of data that are just inherently not good matches for Columnstore?
Oh, yes, strings. All of them, all of them, oh, those strings make Niko unhappy. Niko starts crying when he sees strings in the data warehouses, and he sees them. You know, there are some movies say, "I see dead people." I say, "I see strings in the data warehouse," and I cry. I actually mentioned in my last YouTube video for my Columnstore and batch execution channel that I wish that you know, row group elimination would get some love for the strings, because it's a mess. Avoid strings. When you can convert to anything else, avoid them. And I have a demo for that. So actually, any more questions?
Nope, nothing in Slack.
Okay, good. So I ran this query. Let's see what we were waiting for. Page IOH, right? Not interesting. HSH. Wow, wow, we've got him. That's HTBUILD, right? 2 wait types, 28 milliseconds, right? When will I see this number going balloony and very, very high? When this number will go high. And when this number will go high, when I have a big number of hash match groups operation, and when I have huge number of cores on this VM, because I'm running on Azure and I'm trying not to overspend. I'm running just 4 cores, and I'm limiting to 2 cores the execution sometimes. But if you see which iterator might have caused this wait, I'll do like an uneducated guess. This one, the hash match operation. In my case, I mean, I got just like 1 row, whatever, because I'm doing here a very good, you can see the actual number of the locally aggregated row is 12.6 million rows for the fact online sales table, which is a total table. I'm doing the aggregate predicate push down, so it's very efficient, but I still got some weight. But when you see this HTBUILD weight, it's take a look at your hash joins, hash match operations. Take a look, what is the parallelism? Take a look maybe if you can lower the parallelism and it solves your problem. This is like the basic tool I can give you, okay? So we build in the hash table. It's the build side where the things are happening and making us wait. It's when we are synchronizing the processes. Because, sometimes the work's not distributed equally between the threads, most of the time. HTDelete, well, once you finish the job, once you finished with the joining, you need to delete your table, right? You clean up the mess you've built. Let's see. There is a HTDelete. There is another, I mean, not definitely when you see the nested loops, you're like, what kind of a query are you building, Niko? It's pretty efficient query for what I wanted to show to you. We suffer here more different kind of weights. We still have HTBUILD. We have the CX packet. Woo! We have HTDelete. But you know what? It was all fine. It's 1 millisecond that we wasted. Reasonable time. I don't have here any demos almost that are doing unreasonable things. I'm showing you, easy peasy, all perfect world. But my goal here is to explain. So anybody wants to do a guess? Because we just have nested loops. Where does the wait take place? HTDelete. People are sleeping. Okay, I'll do a guess because people are shy, so am I. It's one of those hash matches. I wish we could go and say, like, can you show me the weights here? I'm not suggesting, but I do suggest one day I would love to have this opportunity. But it's also the thing is how expensive that would be. But maybe I can do some debugging, some extra option where I could, determine that. I mean, I'm fine with being, I'm really fine and grateful of being able to access the weight stats here. This is good enough for me. You will see sometimes huge times for HT delete, especially on 14 and 16 SQL Server. In the later version, it seems to fade less away. And I know that Georgi and all his engineering team are doing incredible work of making sure every version gets some under the hood, non-documented, and some of those probably will never find out improvements for the engine. HT memo, well, it's also something which has to do with the synchronization point before scanning a hash table. Don't have a demo, or do I have a demo for that? No, I do not, because I wanted to limit it. We are already getting pretty far away, but it's something that, read it, look at it. It's non-action item, as Joystack mentions. It's just something you can observe. It's the particular way of how engine deals with the hashing of the table. Renit, well, you'll see this one again as the synchronization point at the end of the scanning hash table, and when you are throwing the output to the non-matching rows. Do we have the output of the non-matching rows in our execution plan? Well, no. Which makes it one of the most exotic weight types. But if you see something like this one being a problem, this is probably something that is buggy, and you need to address it in a very exotic way. Or you have a bug, right? Repartition, well, think about this as the repartition of the parallelism, something you do not want to see, but you will be seeing. It's streams repartition, right? It's, as you can read, it's used after the build side repartition in the hash match aggregate iterator. Unless it's a huge bug, you're out of luck. It's just try to, this is where you need to start looking at a more exotic solution, really. Anything I can show you is this. Not a particular very complicated query. I just removed the foreign key to make it work a little bit more. This one actually does a lot of the weight types I want to show, but they're wacky because it's not like you get all these weight types all the time. Well, you see, I run it and I didn't get it actually. I was drunk, as Eric would say. Let me see if I can get it here. Oh, I got more weight types here. HT delete. So these are really the exotic unicorns most of the time. So I'm out of luck. Sorry. Probably actually, probably I don't know why it happened. So sorry about that. The batch process sorting. This weight type to the batch mode sort operators. And actually, this one is actually become in the last execution even a better example, but this one as well. So when you have the order by, or when the iterator, when the query optimizer, sorry, really tired here. When a query processor inserts the sort iterator, this is where you will see sometimes as the sometimes you will see the weight types going into BP sort. You know, you see this one was one of the bigger one, but page IOH will be the bigger worry in my case. Okay, you if you are seeing on your instances BP sort and you are running non-clustered column store indexes, sometimes, well, there is like an idea. Maybe you don't need the non-clustered column store indexes on this instance. If these are blowing out of the proportion, these are the type on the hybrid HTAP, hybrid transactional analytical processing or operational analytics systems. These are, you will want to tackle those. Okay. You have the trace flags also 4199, 9347, 9349. These are the batch sort mode and the top sort iterator disable trace flags supported document that started with 2016, but you know, test it well. I guess we all need to test more and being able to reproduce the complex workload in order to do a better job. And another one is, I've seen some problems with it, but still love it. In some cases, really awesome. Starting 2016, cumulative update 3, if my memory doesn't fail me. It's a dynamic memory grant for your batch mode operations, and it can be, you know, when you are failing with the sort operation, maybe you just simply need more memory. But from the other side, the intelligent query processing in 2017 and in 19 will be tackling some of those problems. So it will depend. You will need to have your own head, right? This one, seeing this one, this is the way type related to batch mode memory operation, and my current understanding is how the time until the wait time until we get enough memory to proceed with our operation. Seeing this one in the wild with higher frequency, but with a very insignificant wait times, unless you're hitting like something exotic and you're getting at the memory problems. But it's just, you know, it's even its title will point you into the right direction. All right, this one is a good one. So delta stores, you still remember them? The delta stores, when you are not using the bulk load API and you're not loading a couple of 100,000 of rows, when you insert loading data with the in the delta store, what might happen is you load in the data and you have somebody who is trying to access this data. He's scanning the whole column store and he will scan the delta store, right? And he'll scan it and other processes scan, and you load data, mode trickle insert, you reach 1,048,576 rows, and your delta store will become closed. Then the background process, the tuple mover will come, convert this delta store into the row group. Everybody understand that? Easy peasy lemon squeezy, right? I will assume that it is. So what if we are using snapshot or read commit snapshots isolation levels? Like you will use auto-magically in Azure SQL database or anywhere we're using the always-on availability groups, right? Well, you need to access the same version of the data, right? So SQL Server will have to keep a version of the delta store that you were accessing when you started your process. And it will need to keep both versions, the non-compressed, the delta store, and already compressed row group. And this is where you will see this wait type. I see as people are running more and more Columnstore indexes on the availability groups, starting with 2016, for obvious reasons, because availability groups and clustered Columnstore and non-item on 2014. People will see more and more of these kind of problems. solution is, once you are loading the data, load it in bigger chunks. Group it together, more than 100 and 2,400 rows. It will go into already in so-called invisible row group. It will get compressed. No delta stores. I'm anti-delta store. Call me that. I'm into the favor of doing whenever possible, a better job. But of course, delta stores are not unavoidable. Somebody runs it. Oh, I'll correct just this little 10,000 rows and everything will be fine. Oh, you got the delta store. If you want to avoid them, try to, once you finish your process, outer index reorganize, use the documented and supported hint, close all row groups on to get rid of the delta stores. Don't let them hanging. Any questions? I expect questions on this item.
So you said that's limited to non-cluster column store indexes that use versioning in some way, right? Combined with either availability groups or CSI?
Row group version is not limited to, it's a column, universal. I mean, in memory, I have no idea, but I would not expect them to be. But in clustered column store index, let me just rewind here. Here to my architecture slides. That's why they're here. So I can have some support. So imagine you are loading the data. You're loading 10,000 rows. Where do they land? Will they land into the compressed row group? Never. They will land in the delta store for the clustered column store or for the non-clustered column store. That's what delta 4A are for. If you are loading 100, 2,400 or more rows in one single insert, they will land into compressed row group on their own. Okay? And if you are running updates, take it, your delta store. Your information will go into the delta store. Sorry, just it's a funny day today.
We are coming up against the end of the session, Niko. So you're just a little bit past time.
I'm ready to go to sleep and to cry in the shower, all this stuff. So whenever you're dealing with delta stores, and by default, unless you have a very clear ETL process which is finished, and during these ETL windows you're not querying the data, you're dealing with the delta stores. And that's not a good thing. Run with the higher frequency outer index reorganized with compress all row groups. Now with close all row groups. Now compress all row groups on. It will tackle most of the problems. I remember at some clients a couple of years ago, I wrote it, this script. I need actually to publish it in my library, which would basically, I knew that some ETL processes written by other people, they would ignore this, all the good rules, and I would simply run a job after I knew that all of the ETL processes are done, and I would go through all the clustered column store indexes, and I would, like from sys indexes, I will pick all of them, and I would run outer index reorganize. I would compress all row groups on. Just a word of warning, you need to be running this with resource governor, because unless you are confident that you're doing the right thing, outer index reorganize still has this problem, which I'm talking to Microsoft for 1.5 to 2 years about. By default, it can grab up to the limit of your resource governor maximum configured memory, which is 25% by default. So imagine you have 4 terabytes. You run outer index rebuild, it will take you, I don't know, 20 gigs of memory to rebuild your table, because all it needs is to feed a couple of row groups in the memory while processing. And then you run outer index reorganize, and it will grab 1 terabyte because the statistics told us to do so. Sounds scary? Yeah, It is. Because outer index reorganized, even though it is an online process, it still takes some logs, you know, on some things. And grabbing 1 gigabyte or 1 terabyte of memory means that you're not going through the smallest of the gateways, means the query will be throttled, that stuff. But if you configure a process for outer index reorganized and run it after your all ETL finishes, it can do miracles for you. This is a production story. This is nothing like a theory or whatever untested. Really does good stuff for you, okay? All right, so we're trying to advance. Role group operational stats. For all of you reading, you can read. For all of you not reading, I will read it for you. This weight type is associated with looking up role group metadata stats for a given role group ID. Accumulates the value for different log types, blah, blah, blah. It just, it's one of those particular it will help you understand the problem, but you will not be able to tackle it. It's useful, you say, well, that's how it is implemented, right? But this is not how you go into, just not a very practical one. Shared delta store creation. So if you are running by default, no process isolation, no bulk load API failing or throttling down because of the lack of the memory grant, you will be creating shared delta stores, which means multiple processes will try to insert into it. And this weight type has to do with it. And you'll see it a lot of times with the non-clustered Columnstore Index. Okay. It's something that should not be a problem most of the time. So at least in my experience, and I'm not very experienced non-clustered Columnstore indexes user as I am a clustered Columnstore index user, because I'm more of a data warehousing and bigger installation guy. And this is, you try to avoid non-clustered Columnstore there. All right. This is basically a weight type which you will get when you are building something that is Columnstore indexes and you are being throttled. How can you get throttled while building Columnstore indexes? Building or rebuilding them? Very easy. Let me close this. Let's say I'm a bad person. Let's say. Well, some people easily agree with that statement. No, I'm not agreeing. I think I'm not a very bad person. Anthony, do you agree with me?
I think you're fantastic.
Oh, thank you so much. Really appreciate it. So, column store table where we have this one, 800 bytes column. Anybody expect any problem? Well, if I will run a, I will insert with the replicate 750 of the same letters. Anybody expects a problem here with the data when we create a clustered Columnstore index on this table? It will take like I think on around a minute to run to insert 1,100,000 rows into it. Anybody expects a problem? No? Can we go home? All of us?
Based on your earlier comment, I'm expecting a problem just because of the warning against text data.
Yeah, actually, yeah, I failed myself. I gave you the tip, right? Yeah, dummy, Niko. Anything, and I'll throw you the number and don't ask me why. So I'm ready. I will see the execution plan for that, for the index creation, because I can. Anything beyond 32 and the data which is similar but partially with some differences, or the Vertipack engine will consider it so, because it's pretty efficient, actually. Fascinating topic for some presentation, just to dive into the what we can learn from its behavior. It will consider giving you the result that you are not wishing to have. Oh, I have some weights. Let's see. What kind of weights have I got? Wedge, right. But it's evening, and this demo. Oh well, take a look. I've got just one of them, just one, but 719 milliseconds. The Columnstore Index build throttle. Why would it be this weight? Why would it be considered a poisonous weight? If I see a system with this, I already know that there is a problem. That's how bad it is. You can consider this one to be a poisonous weight. Why? Let's take a look at the physical stats of the row groups. I loaded 1.1 million rows. What would be the minimum number of row groups for that? 2. Take a look at the total rows. Every time somebody says, we get 1 million rows per row group, I'm like, see you around. I have a row group with 6,590 rows. What is the reason for trimming? These are 2 residual, and you can see that I have 2 cores which are doing a very good job of distributing the task between them, right? All equal. But most of the time, I'm throttling because of the dictionary size. And it's interesting because if we look at the dictionary, we still, I'm really implying, we still cannot see the real size of the dictionary, because we get in throttling once the dictionary gets to 16 megabytes. Does it look like a 16 megabyte? Not to me. The first number is 7. You know why? Because it's compressed value. We do not have a real size of the dictionary. It's page compressed. So we don't know. Supposedly it hit the limit. That's what it is. And so we throttle. And because of that, when we have these smaller row groups here, we will not get a very fine execution of the batch execution mode. I can guarantee you that. Because it's like, if you are, driving the bicycle through the city, it can be a pretty efficient way, right? If you get like a Ferrari and you go onto some running Formula 1 track, bicycle versus Ferrari, batch execution mode, woohoo, right? Okay, let's go back into the city. You've got your Ferrari. Well, you're out of luck. Oh, turn to the left. Oh, you cannot advance. Oh, that's what will happen with the batch execution mode. That's why it's supposed to be 1 million. This is one of the huge problems. Right now, unsolvable, not reasonably solvable problems for the Columnstore indexes. The other demo I will not use because I'm already overspending your time. Thank you everybody for the patience. Would be, but I'll upload the slides for everyone's enjoyment there. It's like you throttle the memory. In a lot of different ways. You will just reveal something, some table, and you will see it will get huge number of wait time, and it will be memory size, not the dictionary size, because we don't have enough memory to put the whole row group. It will be trimmed, and this is why seeing that weight is always poison. It's just avoidable. Please avoid it if you can. Okay, please avoid. This one is tuple mover, and I already explained it. Well, it's if you see a lot of Columnstore migration background tasks, take a look at what tuple mover is doing, and maybe maybe don't wait for it. I like when I finish the ETL, and I know I'm the only one, outer index reorganized on the Columnstore Index with compress all row groups on. So no closed delta stores, no open delta stores. They are causing us the problem. Okay. This one, unicorn, apparently not even implemented, but I hear sometimes from people saying that they see things that are known to be impossible. So maybe if you see this, you know, take a picture of it, take a selfie, send it to me. we all will enjoy the conversation with the developers because they say it's non-existent, and we will bring them the unicorn, right? Overall recommendation at the end: keep your statistics up to date. They will cause, you know, less problems. Create additional statistics. I mean, multi-column statistics is the most underrated fix for a lot of problems, like ever. And, you know, somebody take this topic, make a presentation, become famous, you know, and buy me some good drinks later, please. Amount of parallelism, sometimes lowering the parallelism, going from 16 to 8, even from 8 to 6 can do miracles. Patching your SQL Server, if I don't have it here, on 2016, because it was probably one of the, if not the greatest release in the terms of the features, like since 2005, definitely. Patch yourself up, patch it up. There are so many fixes over fixes. They can make your query execution significantly better. I've seen it in a lot of places. If you are observing the throttling weights, get rid of the delta stores by using the outer index reorganized with compress all row groups on. Think about the isolation level. Well, triggers is actually, I didn't mention, they will also get you into the snapshot thingy situation. So, I mean, try to avoid them. ETL processes, file code API, group the data together before loading, do the staging, use the partitioning, all the good stuff. Type of index, sometimes you can solve some of the problems by changing on the index, but I'd rather say that this is a very theoretical thing. I considered doing this once, but no, we solved this in a different way. But I had the imagination of where it would do a good thing, but particular system which was more kind of a hybrid one than the defined data warehouse in this case. Nothing more, nothing less. Thank you for your patience. Shoot me your questions, please.
Well, Niko, thank you very much for this incredibly deep dive session into weights on Columnstore. It's much appreciated. There's no questions, but if you have anything else you want to add for the audience, or are you good to go, sir?
Thank you very much. If you're looking to find more, please go find me, find my blog post, shoot me some questions. Right now I'm pretty available on answering them, and thank you very much for your patience. And both of you gentlemen, thank you very much for accompanying me, and I hope everybody will have a great time.